It's Professor Monty again. Let's look at absolute value inequalities again, but let's look at some special cases. Okay, so again, we're going to let a be greater than 0. Now, the big thing to remember here is the absolute value of x measures distance. So it always has to be positive or 0. I can't have a negative distance. We don't, when we talk about distance, we never talk, oh, I went 5 feet that way and I went negative 5 feet that way. It's 5 feet either direction. Okay, so if we have the absolute value of x, so the distance from some point less than some negative number, well, whatever comes out of the absolute value has to be positive or 0. None of those numbers are less than a negative number. So in this case, there's no solution. We may write it this way, the empty set or the null set, but it's because the distance cannot be less than a negative number, there's no solution. There's no answer, there's no number I can put in for x that's going to make this true. The other idea is the absolute value of x is greater than negative a. Well, again, what's coming out of this is positive or 0. All of those numbers are greater than a negative number. So in this case, all real numbers is my answer. We may write it with a block R, but it's all real numbers. So again, the distance must be greater than a negative number. And so all real numbers is going to be our answer. Let's look at some examples. So the first one, I've got the absolute value of 4x minus 3. When is it, for what values of x, is this going to be less than negative 2? Well, it doesn't matter what I plug in for x. Once it comes out of the absolute value, it's going to be positive or it's going to be 0. What if those numbers are less than negative 2? None of them. So immediately when we have absolute value less than a negative, we just say there's no solution. And maybe you'll write out no solution, whatever your teacher wants you to do, but it's the empty set. There are no values of x that work. Now I've got the absolute value is greater than some negative number. Well, if the absolute value is greater than a negative, again, coming out of here, it has to be positive or it has to be 0. How many of those numbers are greater than negative 7? All of them. So we just say, hey, you know what? The answer is all real numbers. Your teacher may want you to write that in interval notation. It's like, okay, negative infinity to infinity. Any value I put in there is going to work. And we can plug in some numbers, whatever you want to. Once it comes out of the absolute value, they're all greater than negative 7. Now this one's a little bit different. So here's an extra bonus one. Absolute value greater than 0. Now remember, the value coming out of the absolute value has to be positive greater than 0 or equal to 0. The equal to 0 is our only issue here. Now this problem, if I wrote the absolute value of x greater than or equal to 0, greater than or equal to 0 means greater than negative a, negative whatever. So this is going to be all real numbers as well. So the same idea, whether it's a greater than, like negative 7 in this case, whether it's a greater than or equal to 0, it's going to be all real numbers because those are the only choices. So in this one, if we go back to absolute value inequalities with a greater than, and I'll link my video where I talk about that to the end of this video, this would say, oh, either x minus 6 is less than negative 0 or x minus 6 is greater than positive 0. Well, negative 0 is just 0. To solve this, I would add 6 to both sides. Either x is less than 6 or, add 6, x is greater than 6. And it looks like, well, isn't that everything? Well, it's everything except 6. So this would be the interval negative infinity to 6, union 6 to infinity, and it's in fact the whole number line except the value 6. If we had a greater than or equal to 0, then we would include the 6 and be all real numbers. It'd be this case, which is this case, which is all real numbers. Okay, these kind of confuse my students a lot, so I spent a little extra time on these and gave you that one additional special case. But think about these. And I've got them also as just absolute value. If you had stuff outside the absolute value, you'd have to get rid of that first and isolate the absolute value, get it all by itself first, and then use one of these ideas. So practice with them. Again, they're a little more difficult, but if you think about what they mean as a distance, I think that'll help you out a lot. So stick with it, hang in there, and you can